The hunt for interesting exoplanets and life forms in the vastness of the universe does not stop. In fact, we are looking for a second Earth, a planet that looks like our home, and where we could finally find cosmic friends. We are not picky, any form of life will suit us, even organisms the size of a bacterium. And these searches are mostly conducted in a habitable zone around other stars. We also call it the habitable zone or the Goldilocks zone. This is an area where conditions, in theory, are suitable for the existence of liquid water on the surface of a planet or satellite. The hotter the star, the more space we will have to explore. Because its habitable zone extends far, and in the conditions of infinite space, about which we still know so little, this is a lot of work. That's why we are particularly interested in red dwarfs. There are hundreds of billions of stars in our galaxy, and probably about 80% of them red dwarfs. These tiny stars are much colder than the Sun. This means that their habitable zones are much smaller and located closer to the star. So we know better where to look for planets. They revolve around their star and at some point pass in front of it and block out part of its light. The Kepler Space Telescope has already helped us find thousands of planets using this method. And most of them revolve around red dwarfs. Some of these planets are similar in size to Earth. And many of them may have almost 25 times more water than our planet. Let's visit the planets that scientists have discovered. I want to show you something special. You've probably heard of super-Earths? They are more massive than Earth, lighter than Neptune. May consist of rock, gas, or a mixture of both. Some of them have a dense atmosphere, while others are sparse, or have no atmosphere at all. Perhaps you know about mini-Neptunes. They are almost as big as Neptune and, unlike ordinary gas giants, have a solid core. Thus, they can maintain a dense atmosphere with water and some other chemicals necessary for life. There are also hot Jupiters. This is very cool, but only if they are far away from us. Perhaps you already have an annoying, unpredictable neighbor that you can't get rid of forever and figure out what he's up to. This is how hot Jupiter behaves. With strong gravity, which can destabilize the orbits of smaller planets or other cosmic bodies in the system. If we had such a neighbor, more comets and asteroids would fall on our surface. Fortunately, our Jupiter is a good and peaceful neighbor who goes about his business, at least for now. But let's take a break from these worlds and imagine that you are traveling on a spaceship and stumble upon a giant eyeball that floats in the darkness of space and looks at the central star in its system. It's not a monster. Hopefully our future space friends won't turn out to be so big and creepy, so it won't blink or turn towards you when you get closer. In fact, this planet is strange, but very cool. And yes, you guessed right, we call such planets eyes. Eye planets are surprisingly common. In addition, some normal planets can also turn into them. Eye planets are formed when matter and dust accumulate around a star and gradually turn into a solid object. It starts spinning. Over time, the gravity of the star attracts the planet and slows down its rotation until it is tied to the star by tidal capture. This means that one hemisphere is always facing the star, and the other is in the dark all the time. We have a good example of this phenomenon. The moon makes a circle around the Earth in a month. It takes the same amount of time for it to turn around its axis once. So we always see the same side of the moon. Who knows, maybe the other side is even more beautiful. If you like craters and all that. So, the most interesting thing about eye planets is their appearance. If there is water on their surface, then on the side facing the star, clean, bright blue oceans are formed, those that we would like to visit when going on an interstellar vacation. And the other side is more suitable for adventurers who like harsh conditions. Since it is in constant darkness, it is most likely very cold and covered with ice. Over the past 30 years, we have discovered so many planets outside the solar system. Super-Earths, of course, are especially interesting. Some of them are not very hospitable due to fog and clouds. This means that it is harder to detect any life there. But scientists still consider them promising places to search for life outside our solar system. Especially super-Earth's eyes. There may be vast oceans on such planets. In the cold half, where eternal night reigns, Arctic conditions await us. It's even cold to look at. But the daytime half looks promising, if we talk about the search for life, because there is a lot of light, water and other pleasant things. One of the places where scientists are looking for life is the super-Earth of the Eye, which is located in the habitable zone of the star closest to our solar system called Proxima b. On its daytime side, there may be conditions and an atmosphere to support life. It is possible that the surface is covered by a deep ocean, very salty, but some life forms can still settle there. Look at the Dead Sea on Earth. It is extremely salty, but some bacteria have evolved to live there. And they feel great having their own small world at their disposal. It's pretty quiet there because there are no animals. A fish accidentally caught in the Dead Sea will not live long. Perhaps bacteria or some other forms of life exist in this potentially very salty ocean on Proxima b. But there is one catch with the open ocean on Proxima b. On the dark side of the planet, the ocean may freeze, and then the sea ice will drift into warmer waters. Thus, the ocean will cool down, and more of it will freeze, even on the sunny side. The only way to prevent global freezing would be an atmosphere with a lot of greenhouse gases, such as carbon dioxide. Such an atmosphere will retain heat from the surface of the planet and will not allow it to escape into space. As happens with Venus, the hottest planet in the solar system. Without an atmosphere, with greenhouse gases, the surface of Proxima b will quickly cool down, so the planet will completely freeze. The opposite scenario is also possible. The heated waters could serve as a heat carrier from warm regions to cold ones. We don't know much about the conditions on the planet yet, so, depending on many factors, Proxima b can turn into a frozen wasteland and a hot foggy world. So the I planet in the habitable zone sounds promising, but its surface may still turn out to be a frozen desert or an endless ocean. Some experts believe that drifting sea ice can cool exoplanets, preventing them from turning into I planets. Instead, many of them become sad, dark snowballs completely covered with ice. A cool place for an interstellar winter vacation. But, unfortunately, not for a search in life. A number of studies show that even the Earth has repeatedly passed through the snowball stages. One of them occurred about 2,200,000,000 years ago, and the other struck the planet 630 million years ago. During these stages, all our beautiful oceans were covered with snow and sea ice. Perhaps the continents were becoming thick ice sheets, at least on the surface. Okay, enough about the icy stuff, I need hot chocolate. Thank you for watching. See you in the next videos.